Okay, so I want to try a chapter, or the PE handout, which you already did the homework on the front side of that page. I want to do the back side, number 5 now. And you'll probably notice I forgot to include the diagram on your page, so pause the video and copy the diagram. Then when you're done, come back. Okay, so the goal is to... the idea here is you've got this piece of cardboard, this rectangular piece of cardboard, and then you're going to cut these squares. These squares are all going to be identical. You're going to cut them out of the corners. And then you'll fold along these red lines that I'm drawing here. And so if you fold along those lines, then you form a box that has no top on it. So it'll look kind of like this right here. And then this would be like the ground of the box back here on the inside. Part of it's covered up by the front wall. And so let me get rid of these X's here. And when you do that, since all these squares along these corner squares that you're going to cut out are going to be equal to each other, then we can call them all X, for the length. X, X, all the way around here. Okay. Now, if I think of this X, when I fold that up, that's really the height, right? So that's X. If I look at this length right here, depending on how you want to look at the box, that could be this length right here. And if you think about it, well, it's the 15 that's given in the diagram minus the top X that's cut off here and the bottom X that's cut off there. So this blue line right here is really 15 minus 2X. And then similarly, this part right here that I'm coloring in green, whoops, let me undo that. This part in green is like this part right there. And that's just 12 minus the X here and minus the X there. So this will be 12 minus 2X. Okay. Now the idea for part A is going to be, well, how big should those squares be that you're cutting out in order to get that box to have a volume of 125 cubic inches? So let's set up a volume formula. Volume of the box is really just length times width times height. So X times 15 minus 2X times 12 minus 2X, and we want that to equal 125. Okay, now you got a bunch of different ways you could try to solve that. Factoring is brutal on this one, and I don't think anybody would actually guess these numbers right anyway if you brought the 125 over and tried to factor that again. So instead, let's just do it graphically. Now, I don't want to deal with the 125 over on the right side here, so instead I'm just going to set it up like this. I'm not going to bother multiplying out because I'm just going to use the calculator to graph the thing. So I'm going to do this. I'll bring the 125 over, so I subtract it, make it equal 0. And then what I'm going to do is I'm going to graph y equals this thing, that same thing that I just wrote, and then see when that crosses the axis. Right, so let me come over to my calculator, go to y equals graph x times 15 minus 2x times 12 minus 2x minus 125. I'll hit graph, and my guess is this is not going to show up right. Now, I don't really know what window we should use. I do know that the x values, negative x isn't going to make any sense, and I'm probably not going to get any bigger. I can't cut a square off that's bigger than 10 inches because the total is 15, and I got to cut off some from the top and some from the bottom. So I'm going to make my, let's go to the window. I'll make the minimum x in my picture 0. The maximum I'll leave at 10. And then I don't really know what to make for the min and max. I'll try, for the y's, I'll try negative 50 to 50 and just see how that picture looks, and then we'll come back and adjust it. Oops. 50. And then I'll make the y scale. So each tick mark will be 10 units apart now on the Y scale. So let's graph that, see how it looks. Okay, so that looks a little better. I want to get the top here, so I'll probably increase the Y max just maybe another 10, 20 units. It looks like I got to go pretty low here, so maybe I'll make that like negative, let's see, that was negative 50. Maybe I'll make it like negative 150. So let me do that. Go back to window. I'll make that negative 150. I'll make this one maybe 70. And I'll leave the scaling at 1 tick mark every 10 units. Sweet. Alright, so let me scroll down a little bit so we can work on this a little bit better. Okay, so let's draw the graph. Now, I get to do this. There's my graph. I'm going to copy it. Edit. Copy. Paste. There. Now you have to draw it. I remember I want you guys to start including your scale. So my scale here, what did I say it was? It was 0 to 10 for the x's, and for the y's it was negative 150 to 70. Okay. Now I need the zeros, because I remember I set up the equation so that I should care about when it equals 0. So here's a 0, here's a 0, there's a 0. Okay, so I'm going to go back to the graph. I need to find those zeros, so I'm going to go second calc. Whoops, got to do that one more time. Second calc. I'm going to go to the option for 0. And then I need to figure out, let's figure out that first one. So remember, these were tick marks of 1 each. So it's somewhere, the left bound, if I make the left bound 0 and the right bound 2, it'll search for that guy, which ought to be close to 1. It looks like it is 1. So I'm going to type in for the left bound 0. And for the right bound, I'll type in 2. And then I'll guess right about there. That's close enough. Okay, so it's not 1, it's 0.942. Okay, so right here, this is 0.942. This one right here looks like it's close to 4. So let's see, second calc 0. So I'm going to say it's between 3 and 4. So for left bound 3, for right bound 4, I'll guess it's about 3.5. 3.778. And then the last one here, let's do that, second calc 0. That looks like it's between 8 and 9. So I'm going to say left bound 8, right bound 9. You can also just move the cursor if that's what you're more familiar with. And then maybe like 8.8, something like that for the guess. Not a bad guess. So 8.780. Okay, so there are 3 intersection points with the x-axis. So that means that the volume is 0 when x is 0.942, 0.3778, and 8.780. But really it's not. Really the only answers are this one and this one. And the reason is, if you think about how big the x's are here that you can cut out of the box, so let me use a different color. Let's use red. This is 15, this is 12, right? On this side, the most I could cut is half of the 15, right? So that's only 7.5. So I can't really cut out anything bigger than 7.5 along this side. But the 12, that even limits me more. I can't cut anything out bigger than 6 on both sides, right? So really, I should only care about this graph up to 1, 2, 3, 4, 5, 6. I should really only care up about this part of the picture. Nothing bigger than x equals 6, because I can't cut anything bigger than 6, really. So really, the only places that I could cut an x value would be 0.942 or 3.778. So those are my two answers when the width, let's see, how's the question phrased? What size corner squares? So squares should be 0.942 inches or 3.778 inches on each side. So that's part A. Okay, part B says same deal but more than 125 cubic inches. Okay, so really then what you're solving is, this is all part A here. Part B is really asking this question. I want x times 15 minus 2x times 12 minus 2x to be more than 125. Okay, well that's the same thing as asking this question. If I bring that 125 over, minus 125, when is that bigger than 0? When's that positive? Well, if you just go back to the same exact graph, it's positive here, right? So that's everything between 0.942 and 3.778, not including those, because otherwise that's exactly going to be 125 units for the volume. So I want to just write this as an interval. I would say, let's say the side length of the square has to be between 3.778 for the big side and 0.942 on the lower side. Okay. Let me scroll down some more. Or actually, first let's go back up. This one says, same deal, but now I want the volume to be at most 125 cubic inches. Okay, so that's really asking this question. That's saying, when is the volume less than 125? It can't be bigger than that. At most, does that mean equal to? Yeah, I suppose it really means this. At most 125, that sounds to me like it up to and including 125. So, now this is really going to be the same exact kind of work. I'm going to bring the 125 back over. Less than or equal to 0 now. So I'm still concerned with the zeros. Now that's negative when I'll highlight this in green. For this part here and this part here. Remember, this is the 6. This is the cutoff. I can't get bigger than 6 for cutting out those squares, or else I'm well, it's just impossible if the whole thing's only 12 inches to begin with on that side. So my maximum is 6. My minimum, I can't cut less than 0, so that's why I'm not even bothering to look at the negative side of this graph over here. That doesn't matter. Okay, so the smallest square I could cut out is really 0 units. And then that would go up to, oh, yeah, so I'm going to do this in interval notation. Well, no, let's do it in just like we did this. So the side length of the square could be between 0 or 0.942. But remember, I'm going to include this one. And we'll say that you could technically cut 0. That's just cutting air then. Okay. Or I could go from 3.778 up to 6. Okay. If we did these in interval notation instead, then this part B would just be 0.942, comma 3.778. And down here in part C, I would get 0, comma 0.942, union 3.778, comma 6. Okay, hope that makes sense.